So thank you, Bill. Thank you, Mahesh. Thanks, AI Camp. My name is Karthik Talamadupula. I am Director of Research at Symbl.ai, and we are a startup based out of Seattle and San Francisco, and Bangalore and Pune and some other places. And we're essentially a conversational intelligence and conversation AI company. And in today's talk, I'm going to give you guys a brief overview of uh, the use of language models for human conversations, for iterating over communication data. And I'll be presenting, we've now trained our own LLM for human conversations called Nebula, and I'll be presenting the Nebula system. Excuse me. This talk is coming to you live from New Orleans, which has become the center of the AI universe for this week. Because as some of you might know, the NeurIPS Machine Learning and AI conference is happening in New Orleans right now. Tomorrow is the last day of the conference. So those are some of the pictures that I've thrown up there. So this talk is coming to you from the nerve center of everything that's happening in AI and ML, at least for this week. There's going to be barcodes throughout the slides in case you want more information on something. So this barcode, for example, leads to my LinkedIn page. So in case you guys have questions, in case you want to connect about something, you can basically follow me by following that barcode. Feel free to take pictures of the slides as I'm showing you some of the information. A lot of the papers and other things, I'll have barcodes to those so that you guys can uh, follow those up on your own time. And again, if you have questions, reach back out to me. That's my website. That's also my Twitter handle at KR_T, and you know where to find me. Okay, so let me just give you guys a very quick overview of the talk itself. I apologize for my voice. I've been talking all week to people at the conference, and I'm kind of at I think, the end of my voice. So here's an agenda for the talk. I'll start with a very quick history of conversational AI. And when I say history, I really do mean history. I mean all the way from the beginning of AI itself as a field back in the 1950s. So we'll do a very quick run through some of that history, ending up basically in the paradigm of neural conversational AI research. And that's really the basis of a lot of the advancements that we're seeing today, including large language models. So we'll do that. I guess you can think of that more as a research/academic part of the talk. And then part two, where I'll try to spend more of my time, will be more of the real world part of the talk. So that will be more about what kinds of things do businesses look for when they look to buy and deploy large language models today. I'll talk a little bit about our conversation intelligence platform and the kind of data that our large language model was trained on. And then I'll present the Nebula model itself. If there's time, I'll try to do a quick demo of the model as well, just to show you guys how the model works and so forth. And then I'll also talk about a few research ideas that we've been working on and so forth. So let me start with part one. And this is just a picture that I always like to show. This is a graphic from 1985, from the 1980s. And this just shows you that if you think the current hype cycle that we're in is the first time that AI is going through a hype cycle, you're very much mistaken. Like I said, this week I've been at NeurIPS. This conference basically just grows exponentially in size. I think this time there are well over 15,000 people at this conference. I still remember the days like a few years back, maybe a decade and a half ago, when NeurIPS used to be 500 people at most. And so that really is an exponential increase. There are all sorts of people here. There are researchers, there are product people, there are startup founders, there are VCs, there are academicians, all sorts of people. But this is just by way of trying to show you that, this is not the first AI hype cycle that's happened. Hype cycles like this have happened in the past. Hopefully this one doesn't burst. Hopefully this is a bubble that keeps on going for all of our sakes. But I just thought it was an interesting history to look at. So here's a more sort of detailed history of conversational AI, and here's where I mentioned that there is a very rich history to conversational AI dating back almost to the origin of the field of AI itself, which started as a workshop at Dartmouth in 1956. So in 66, there was the first, I guess, what you would call really deployed conversational AI system. This was the ELIZA chatbot out of MIT. This was designed by a guy called Joe Weizenbaum. And I'm sure a lot of you have heard of ELIZA. Some of you have potentially played with implementations of ELIZA and ELIZA-like systems. Pretty much, Eliza was kind of the standard bearer for conversational AI for a long time. Then we got into more of the rule-based plus machine learning models mixed systems. So we started transitioning from more of a rule-based era to more of a machine learning-based era. And that's when a lot of these smart assistants started coming out, right? So this was more in the previous decade. We had the Google Assistants and Alexas and all of these other things. And then, of course, in 2020, there was this transformational transformer paper, no pun. And that was really the thing that brought together this era of big, 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 deep neural networks with huge amounts of data, networks that were pre-trained and shown very large amounts of data. And then, of course, since then, the growth has just been completely exponential. You'll see that this slide, of course, is quite dated at this point because it ends at 2022. And we've seen a lot of advances this year. In fact, at this conference, they're calling this the year of the LLM, which is, I think, a reasonable thing to say, just because of all of the things that have happened with LLMs. One thing I want to give a shout out to, this is a great article. If you're into AI and if you're into it from a conversational lens, I would highly recommend Googling this article from The Guardian and reading it. It's about Joe Weizenbaum and how he created ELIZA, but it's also more of a philosophical investigation into AI and what that means for us. I found it extremely great to read. Um, just as, conversational AI has been developing, so did conversational systems. So these are all systems I think all of us are familiar with. Of course, the early 90s, there were the phone-based systems, which kind of tried to do keyword spotting. So you would, pick up a phone and then you had an automated system on the other end that would recognize only very specific, very narrow phrases. That kind of got generalized into intent determination. So Nuance did a lot of work in this space, Nuance Systems. So there you no longer had to say a specific word or a specific set of keywords, but you could actually express yourself however you wanted. And in the back end, there was a machine learning model that was trying to match the intent. And then, of course, that generalized further. There was IBM's Watson. There was that Kalo project that was funded by DARPA, which eventually got spun out into Siri. And then, of course, that came to Apple and all of that. And then, of course, all the smart assistants that we've been talking about. So this is more of a product-centric view of conversational systems. And finally, you can also look at a research-centric view, right? An AI research-centric view. So here I'm giving you a timeline of basically from around 2015, when really the era of deep neural networks took hold, a history of neural conversational AI research. So you can see that this starts from sort of Oriol Vinyals's paper on neural conversational models, and then all the way to things like the GPTs, the generative transformers, and the transformer-based models and everything built on top of that. One of the specific papers that I want to talk about is actually some work that we did back in IBM research. So this was our work on multi-resolution recurrent neural networks, or Mr. RNN. And the idea behind this was done in conjunction with Yoshua Bengio's group and a couple of folks from the University of Montreal. It wasn't called Mila then, it was called the University of Montreal, the center. And so the idea here was basically, instead of having a single network, to basically have a hierarchical I guess not layers, but two-level network. One of them was for the natural language representation, and then the other one was for a coarse representation. So the idea was that instead of passing in natural language and expecting natural language out, you would pass in natural language as well as a coarse representation of that natural language. So if I wanted to give you guys an example, if you think of like a technical support kind of use case, instead of just passing in the dialogue or the context of the dialogue, you pass in both the dialogue itself, but also a coarse representation of that dialogue, which only focuses on the entities and the actions in that dialogue. And so that way you're giving your model more guidance to produce more relevant output. So essentially what you're doing on a very high level is you're taking your model from being very chatty and conversational to becoming more of a goal-driven problem-solving kind of agent, right? Again, it's not really planning. I don't think, even today, large language models can't really plan or reason, and we'll talk about that towards the end of the talk. But really what it was doing was more of a, it was trying to be more specific in its output. And as we all know, when we're chatting now with the, chat GPTs of the world and in any other LLMs, when they start getting specific is when they start getting useful, right? When their output starts becoming more specific. So this was some work that we did way back in 2016, 2017. And there is a QR code on this slide at the bottom right in case you want to actually retrieve the paper and you want to look at it. And this paper has been built upon by a lot of successive work in this area, especially in the area of conversation systems and dialogue systems and so forth. And I promise that that's going to be the most technical slide that I'll show you in the entire talk. So that kind of concludes, a very quick overview of some of the history of what brought us here. Let me switch quickly into part two, right, which is more of the real world. What do real world deployments of LLMs look like today? What are the kinds of things that people look for in LLMs? So this is a graphic that I created that I came up with a few months back as we were talking to a lot of customers, a lot of potential customers, a lot of potential users, companies that wanted to use large language models. And so I put together this chart basically showing what was important for these companies and where do they go, like where do they get these from, right? So it became very clear that there were two different worlds of large language model commercialization. So world one was, smaller companies, startups like our company and our model. And then world two was much larger companies that, like the OpenAIs of the world and the Google, Microsoft, Anthropic, and well, I guess Anthropic and Amazon are kind of the same thing now, and Meta and so forth. And so you can see in this table that there are a few things that stand out, right? There are some very key differences when you actually, so imagine you are a company, right? And you are, let's say, a reasonably large company or a mid-sized company. You don't have your own AI team, either because you don't want to take up that expense, or more likely because you can't find the talent for it, because AI talent is at a premium now. And when I say AI talent, I mean really people who can train LLMs from scratch, people who can, work on the machine learning aspects of it. That talent is very hard to find today. So most companies, when they're faced with this build versus buy decision, they tend to go with the buy decision, right? So now if you're one of those companies who's trying to make that decision of which LLM should I go with, these are some of the factors that are going to become important for you, right? So one key factor is incumbency, right? So is the company that you're trying to buy from, are they someone who knows the domains and use cases that you're going to work on? Do they know it really well, right? Are they someone who just stood up a model like yesterday and they're trying to sell that model? Or are they actually somebody who has incumbency in this space, who knows, what it takes to succeed in the kind of use cases and the kinds of domains that you're working with? That is a very important thing to look at, obviously. There's also this notion of support, right? So support can include a lot of things. Support includes various model iterations. It includes support for fine tuning, right? So a lot of people are often not happy with a base model. They usually want, they want to be able to fine tune it with their data. Of course, also there's this notion of update velocity. How often do you deliver updates for your models? There's also this notion of deployment flexibility. So most of the LLMs that you and I play with today, they're all basically cloud-based LLMs, which means that you need to send your data to, on the cloud to the LLM, and then it comes back with the output and sends that back to you. Now, obviously, there are a lot of use cases, especially enterprise and heavily regulated use cases, where this is simply not an option, right? So then you have to offer something like an on-prem deployment of these models as well. And then, of course, that comes with its own challenges in terms of being able to deploy these models, being able to maintain some of these models, and so forth. Um, there's also this question of data reuse, right? So this is kind of tied into this notion of on-prem versus multi-cloud. A lot of companies want full control over their data, mostly because their data is often their clients' data, right? So those of you who work for large enterprise companies know what I'm talking about, right? Often the data that you're dealing with is actually your customers' data, and they're very, very, particular about how that data is handled. And finally, of course, there's this notion of the quality of the output that comes out of the LLMs itself, right? So obviously, you don't want your LLMs producing hallucinations. You want some notion, some guarantee on the output that comes from the language model. So you want to have this notion of guardrails. And I think one of the important things here is basically when you're training, when you're pre-training your model, right, you want to be able to empower your model to come back and actually say no, right? So when your model doesn't know the answer with a high degree of confidence, for example, right? And usually, most often hallucinations happen when you are trying to get your model to produce output on a task which is out of distribution to the kinds of tasks that your model has been trained on, right? To the kind of data that your model has been trained on. So if it encounters something like that, you really want your model to come back and say, no, I have very low confidence in this, so I cannot answer this. And most of today's models, right, notably the GPT series of models, GPT 3.5, GPT 4, they go out of their way to please you, right? So if you ask it an impossible question, or you ask it a question, a trick question that only has a wrong answer, it'll still come back and try to please you and answer that question. And that's not something you want, right? You want a model that can actually give you factual answers. So LLMs, again, they're really just data processing machines at the end of the day, right? I'm a big XKCD nerd. I don't know, those of you in the audience who follow XKCD, this has never been more true, right? LLMs literally at this point, especially, the decoder-based models, you throw in a bunch of data and then you expect something to come out the other end, right? And all we're doing is we're doing post-facto rationalization, and we're hoping that the output that comes out is right. And sometimes it is, and sometimes it isn't. Um, Here's a quick, I'm just quickly going to flash our platform. Like I said, we are a conversational intelligence company. We have an end-to-end AI platform, a conversational intelligence and understanding platform. Not going to go into too many of the details of this slide. It's probably a bit small for you guys anyway. I just want to point out that, I'm trying to show you where the language models, where the LLM sits in the context of our larger platform, right? So this bright pink box that you see, that's the Nebula model that I'm talking about today, right? But it is embedded in a larger context, right? So our platform is a fully multimodal platform. It can handle audio data, video data, text. So even today, right, you can sign up for a free developer account on our platform. And if you have, conversation data, whether that's in the form of like a Zoom recording, let's say, a WebEx recording, maybe you have a transcript, maybe you have, chat logs, you can upload all of those and you can get all of these kinds of analytics and analysis out of our platform. And of course, the large language model basically makes it now, it combines all of these into a single API call, right? So previously it used to be that you'd call a task specific model for very specific things. Like if you wanted to extract intents, you would call one model. If you wanted to extract entities, you would call another model. You wanted to generate sentiment analysis, another model. So now all of these and more are basically being done by the large language model. And really, you just need to make one API call for that. So how did we go about creating this LLM for conversation, right? So it was on the back of a lot of communication data. So this is what I meant when I said earlier that, I'm going to show you guys the kind of communication data that I'm talking about and the kind of tasks that we train the model on. So when we say conversation tasks, really we mean things like this. And again, this is a non-exhaustive list. The complete list of tasks is like 60 plus tasks essentially. But these are some of the more important ones, right? So when you think about conversation, right, what are the things you think about? You think about summarizing a conversation, right? If you have a very long conversation, you want to get the gist of it, you want to summarize the conversation. You think about things like chain of thought reasoning, right? So you might want to you might want to call the LLM multiple times, right? And you might want to do a chain of thought kind of process in order to arrive at the final answer. Of course, you think of Q&A, you think of sentiment analysis, just note taking and generating action items from the conversation, intent detection, right? Both general and generic intents, but also intents with like few shot learning, right? Zero shot and few shot intent extraction. And then one thing I want to point out here is that in addition to all of the positive training samples, right? It's also very important to show your LLM some examples of negative samples, right? So in this list, something like paradoxical data, right? Or nonsensical text or irrelevant text or inappropriate text, right? These are all negative examples of things that you don't want your language model to be outputting to an end user, right? But you still have to show it that during the training phase, right? Because you need to tell your model, it's not enough to just tell your model produce good output, right? It's a machine learning model. It's not going to know, that high level statement. So you have to give it examples of the kinds of text that it really should suppress, that it should not be producing. And so that's an important part of this, right? That you need to also show it data along those lines. And then also in terms of the data itself, right? So in terms of what are the domains that this data comes from, right? Is it like, is there a breadth of conversation data? So this is an example of a lot of the different kinds of domains that our data comes from, right? So there's sales calls, mostly B2B kind of sales calls, but also there's a bit of B2C in there. Customer support interactions, contact center, basically people who call in and try to get problems solved and so forth. But then there's also a lot of emails, chats, internal meetings, webinar, minutes of meetings, webinars. things like events. And then there's also a lot of media, right? Streaming media. So things like YouTube videos, things like podcasts. So a lot of people, for example, one of the big use cases of our platform prior to the large language model was people who are creating podcasts, right? If they are trying to provide closed captioning on their podcast, right, they would use our platform to basically generate the transcripts and to do the speaker diarization and all of that, right? So that they can automate the process of creating a transcript for their podcast, for example, right? So our model has basically been trained on a lot of a broad variety of different domains and a broad variety of different tasks. And that is essentially what makes it special, what makes it a conversational AI model. And so that's the Nebula LLM that we're talking about today. So let me give you some quick overview of the LLM itself, right? So the kinds of things that it's trained on. I already showed you it's trained for multi-party human conversation understanding, specializes on conversational tasks. It's trained on all forms of communication data. We just went through that. Currently, the model has a 16K token context window, right? So context window is basically the maximum length of the text that you can give the model in one shot, in one particular go. So 16K tokens, with our tokenizer, that's roughly equal to about 12,000 words, right? So 12,000 words will basically give you something like 45 to 50 minutes of conversation, right? So that's a pretty big context window, right? And we are now actively working with increasing the context window to 32 and 64K as well, right? And so that will easily cover more than an hour's worth of conversation. One question that does come up here is it worth keeping on increasing your context window size, right? So there are some models today, for example, Claude 2.0 had a 100K context window, and Claude 2.1, which came out recently, has a 200K context window. That's not necessarily always a good thing, right? So the longer your context gets, the less likely your model is to pay attention to the text in the middle of the context, right? So think of the context basically as a long, string of dough, like when you're making pizza or you're making roti or whatever, right? The more you stretch that, the more likely it is that the attention of the model will break in the middle, right? And the model will only pay attention to the text that is there at the beginning and at the end of that context window as the context window gets longer and longer. So a more principled way of doing this obviously is with things like RAG, retrieval augmented generation. So I'll talk about an embedding model that we have as well, towards the end as I go through the talk. The model is also multilingual out of the box. So in addition to English, it supports a few other languages. Now, of course, this is a function of the kind of data that you pre-train the model on. Finally, there is a QR code on this slide, right? That will take you to the sign up page for our model. So our model is currently in private beta. So we've been basically deploying it with early customers, trying to get some feedback, trying to tweak the model. But basically, if you or your company have a need for a conversational LLM, then I would strongly suggest, going to the website there and signing up for it. We'll also be opening up to public beta soon, I think next month. So if you sign up on the wait list, then you'll be one of the first people to actually be notified about the availability of the model. And then you can be one of the first people to test the model out and, use it for your use cases and so forth. So, I would strongly encourage you, take a picture of that. The QR code takes you to the sign up website. Or, there's the link on that as well, but usually the QR code is easier. So that's as far as the LLM is concerned. Let me give you some quick results as well, right? Some benchmarking. And again, some of these numbers now are maybe a couple of months old, but even at that point, the numbers were pretty good. So one of the extensive evaluations we did with our model was against GPT 3.5 Turbo, right? Which until GPT 4 came out was, the best model out there, which everybody was using in commercial applications. And so we ran these evaluations on the Helm framework, which is the holistic evaluation of language models from Stanford University. So you can see here, for example, that Nebula beats GPT 3.5 Turbo on standard accuracy metrics like Rouge and the F1 score and all of that. We also measured basically the performance on summarization, because summarization is one of those very key tasks for all kinds of conversational tasks. Like basically anything that you're trying to do, any generative output that you're trying to produce from a conversation usually goes through summarization. You have to first produce a summary of that conversation, and then you can produce, action items, or you can produce next steps, or you can produce an email or whatever it is, right? So you can see that even on summarization, Nebula does better than GPT 3.5 Turbo, right? So it's basically better than that model across a wide variety of conversation specific tasks. And then the other thing we also did was in addition to evaluating on Helm, we also evaluated on open data sets, right? So one example of such an open data set is something called Hella Swag, right? So this is a well-accepted data set in the NLP community. It's been around for 2 years or 3 years now. And the idea is that basically it is a common sense conversation completion benchmark, right? And so it is a good indicator of whether your model is a good conversational model. And I've thrown some examples of Hella Swag tasks on the left, so you can read them yourself, right? It's basically it's a multiple choice data set where you're given a sentence or a set of sentences, and you're given four options, and you have to pick the option that is the best completion, right, for that sentence or this series of sentences. And so you can see the performance of Nebula here. The reason that I'm showing you guys this table is, notice the performance numbers, right? So EM stands for exact match. That's the exact match metric, which basically means you only get the points if you choose the correct option, the correct multiple choice option, right? But what I want you to notice is the correlation between model size and the results, right? So Nebula, in spite of being much smaller than a lot of these other models, other proprietary models that are on this chart, it's still able to do just as well or even better than some of those other models, right? And the reason for that, even though it's a much smaller model in terms of the parameter size, is because Nebula has been trained on a lot of conversation data that none of these other models have access to, right? So a lot of this conversation data is proprietary data that we got by making our platform available to developers like yourselves, right? So developers who signed up, they get free access to our platform, and then we get access to their data. And that data is basically proprietary. It's stored by us. It's not out on the internet anywhere else. And so none of the other models, not OpenAI, none of the other companies, not OpenAI, not Anthropic, not AI 21, anyone, they don't have access to that. Which is why even with a much smaller model size, we're able to get performance that is equivalent or even better than some of these models. Another data set that we tested on is this ARC data set, the AI2 reasoning challenge. So I've given you guys some examples of this as well. By the way, there are, research papers on all of these. If you guys want to read further on that and so on, just take a picture of the slide and then you can search for the name of that paper. And then a similar table here, right? So here we evaluated both the Nebula. So Nebula has two ways of deployment, right? One is an instruct fine-tuned model, and then one is a chat version of it. And so we tested that against obviously things like GPT 3.5 and the Jurassic models and so on. And you can see again that, a Nebula does have much better performance on both the ARC-easy and ARC-hard fragments of the ARC dataset. And it's still, again, significantly smaller than a lot of these other models. So that's as far as some of the empirical results on the model go, right? And so this is one of those things that, when you talk to customers, one of the first things they want to see is what is the comparison of your model compared to other LLMs. Um, Okay. And I also quickly just want to show you guys Nebula embeddings, right? So we also have, in addition to the language model, an embedding model that we trained, right? Because again, if you have a lot of specific proprietary data that you're training on, it makes sense also to train an embedding model. And so our embedding model is comparative with, and it's actually better than OpenAI's ADA 002 embedding. We tested that on a bunch of, on the MTEB leaderboard, which is like the standard leaderboard for evaluating embedding models. So that's something that we have available. And now a lot of our customers are starting to build retrieval augmented generation pipelines, right? RAG pipelines. And so the use of the embedding model, the vectorization is very useful over there. So that's something that we also have. This is just a quick slide on domain adaptation, right? This is actually true of most LLMs. This is not specific to the Nebula LLM, right? So you can basically generalize this slide. Most LLMs, they do have to be adapted in some sense or the other before they are commercially deployed in any domain, right? And so these are roughly the three kinds of domain adaptation that can happen, right? Step one, which is the easiest one, usually the least effort, is prompt engineering and management, right? So we've all heard of prompt engineering and, how to change the prompts to get the right output and so on. But then sometimes that's not enough. Sometimes you want to use data and knowledge from external sources and documents. That's when RAG comes in, retrieval augmented generation. So I talked about that a little bit. And then, of course, the final step in domain adaptation for large language models is to do fine tuning, right? So fine tuning basically enhances the underlying model. It changes the weights and the parameters with new data. It requires additional data, obviously, to do this. And it's also usually the most expensive and time consuming of all of these domain adaptation techniques, right? And again, like I said, this is general across all LLMs. This is not specific to Nebula. So tomorrow somebody comes and talks to you about domain adaptation, you know that these are the steps basically that they're going to be talking about. Um, we are actively working on a lot of research areas. I usually flash this slide basically if in case in the audience there are people who are working on similar things and want to collaborate, we look for interns and we do all sorts of things. So these are 6 of the areas that we're actually doing some active research in. Active learning, which is basically you keep learning. You don't do just one pre-training phase and then stop. You constantly keep updating the model, right? And you keep actively learning. Learning to reason, that's one big thing. So I've been at this NeurIPS conference all week, and I can tell you that the next frontier for LLMs, all of 2024, is basically going to be about, can large language models do reasoning, right? And if they can't, how do we extend them? How do we create new representations and new architectures so that large language models can actually generalize and can actually do reasoning? We have our own internal conversation understanding and task evaluation framework. It's called CUTE. That's the acronym over there. And that is actually a framework that allows us to evaluate both our model as well as other models and find out, where we are lacking, where we need to improve, and so on. So that's something that we constantly do. Of course, data gathering and engineering goes without saying. Data is the most important part of training any LLM. So we pay a lot of attention to that. And then there's these two twin things of, multimodality as well as multilinguality. I'll actually talk about that very briefly. This is a blog post that I wrote a couple of months ago that QR code will take you to the link there. But the basic idea is that not all languages are equal, right? When you're talking about multilinguality, especially in large language models, right? If you take a high resource language like English or Spanish, those have a lot of data, right? And conversely, what ends up happening also is they tend to be the least expensive languages to run an LLM for, right? Because remember, LLM billing happens on the basis of what's called tokens, right? So you tokenize the words and the sentences that go into a language model, and then the billing that you do is based on the input tokens and the output tokens that are consumed by the model while reading your input and while rendering your output, right? Now, the problem is across different languages, this tokenization varies widely, right? And so tokenizers and hence the cost of calling an LLM are not language agnostic, right? So TLDR, what this really means is tomorrow, if you have an LLM, let's say, that's able to produce output in Hindi or in Kannada or in Tamil or whatever, right? It will actually cost you significantly more for semantically equivalent output to produce the thing in, let's say, an Indian language versus to produce it in English, right? And this is an artifact of the fact that most of the data on the internet, which is what LLMs are mostly trained on, mostly pre-trained on, most of that data is in English, right? So until we kind of correct that discrepancy, right, there will always be this artifact that, other languages, low resource languages, are much harder, to work with and are much more expensive to work with. So that's something, there's a lot of active research that goes on, even in Microsoft research in Bangalore in India, a lot of great papers on this. So my blog post basically references a whole bunch of those papers in case that is something that you are interested in. Um, I'm not going to go too much into this. These are some of the daily conversational challenges that we see with LLMs, right? So if you're trying to use large language models for conversational tasks, you get all of these problems, diversity, consistency, knowledge, responding with empathy and being more human-like, the controllability of the LLM, can you make the output not deterministic, but at least predictable, right? So that there are no surprises, and also the versatility of these things. We do have a roadmap. This is, I'll just quickly end with this. Like I said, we are looking to increase the context window size. We're also looking to increase the size of the embeddings. The interaction mode, like I said, we have both an instruct and chat-based mode. We are looking into this more active learning, continual interaction kind of framework. And of course, we're looking to go to full multimodal support and also many more languages supported in the model. Okay, let me quickly end with a demo of the model and then I'll go back to my last slide. So what I'm going to show you basically is our instruct version of the model, and then I'll also quickly show you a chat version of the model. And like I said, this is something that, we're still, oh, let's see. Great. Sorry, this is just something that I needed to probably expired over there. Okay, I think that's not going to work. I'll have to, I think, skip that demo. But again, you can apply for access to the language model. We're in private beta, but we will be expanding out to public beta very soon. So you can go to that link over there, and you can sign up for access both to our platform, which is free, and to the language model. If you work for a company that actually is looking actively for a language model, or let's say you use some other model, but you would really like to test out a conversation specific model, please reach out to me. I'm happy to put you in touch with our team. We can discuss, whether it's the right model for you guys. You can find me on LinkedIn if you have any questions. We're also, like I said, we are constantly looking for AI ML interns to work with. So if you're somebody who has significant experience in AI and machine learning, please do reach out. That QR code will take you to my LinkedIn post that mentions that. Yeah, and then I'll end with that and see if there are any questions. Thank you guys for your time. I know virtual talks are not that easy to be engaged with, so appreciate all of the time, and thank you.
Thank you, Karthik. Any questions? Any questions for Karthik? Can you come here?
Hey Karthik, I'm Shine.
Hey,
I have
yes, go ahead.
two questions apparently. So one is how was the hyperparameter tuning, like the how we came with the parameters of 32 billion that came in, and the second question is that how is the deployment and consumption of this is in the real world? Like how is it like distributed, and how is the APIs working and stuff?
Right, right. Yeah, great questions. So as far as the number of parameters, like, the 42 billion number, like I'll tell you briefly how we started experimenting with the model, right? So obviously it's been almost a year and a half of playing around and trying to pre-train the model and experiment with it and so on, right? So the first thing that we tried that anybody would try, last year was to take one of the existing open source models, right? And try to fine tune that model with some of the conversation data. But then we found very quickly that the performance of those models is really not that good. Like if you run it on one of these evaluation benchmarks, right? It's not that good. And that's because when you're doing fine tuning, really you're just updating like, some of the layers and some of the parameters of the network, right? And you're forgetting a lot of the other emergent abilities of the large language model, right? So then we decided, okay, fine, then we do need to pre-train this thing. We do need to, start from some earlier stage. And then, of course, we did different iterations of it as POCs. We tried to run like smaller versions first. And then we decided, basically, we settled on 42 billion as a, reasonable number. Kind of, it wasn't too big, but it also wasn't too small. It was just the right size that it could basically specialize on conversation data while still having some of these emergent, more general properties, right? Being able to exhibit some reasoning like behaviors and so on and so forth. So that's as far as the first question is concerned. And then the second one, about the availability, right, and the deployment of the model. Like I said, we have two deployment models. One is on the internet, right? We are like we are hosted on like VPCs on, let's say, Google Cloud Platform, but it can be on any vendor of your choice. And then there's just an API access basically. So there's an API that you hit. You have a key, and that's it. It's literally just that. It's one API call, and then you basically set the prompt, and you set the system prompt, and maybe if you want to take play around with some of the hyperparameters, you can do that as well. But we also offer an on-prem version, like I said, right? And so there, what we do is we basically ship a Dockerized container to our customers, and they basically deploy it on their end, and so they can run it within their own compute and within their own, clusters or whatever.
Thank you, Karthik. Any other questions?
Thank you, Karthik, for the wonderful session. Really informative. It shows your research, what you have done, and then what is the contribution you made for that LM world. So we have seen all the models right now. Everybody is across the globe. They are developing the different LLM models and all. And what in Symbl, I think you were doing is a Nebula is the model we can look for. I think you are going from 4K to 8K and 32K and all. But still, like the foundational model, what we hear and then what we read is still most of us, it looks a kind of a black box. And how that preparation happens, maybe you can little bit explain about how do we prepare ourselves for the foundation model company like Symbl or any other big companies? That would be helpful for the people.
Yeah. Yeah, that's a great question, because that is actually part of, for us, the journey was filled with a lot of trial and error, right? Which I was just describing, like, building POCs, trying to get the data right, trying to understand if something was actually something intelligent was actually being trained, if the output was looking good, and so on, right? I would say that this is a problem that's now going away quite a bit, right? So some of you might have followed, Mistral, which is one of the sort of open source companies that's out there. They just released a new mixed trial model, which is based on a mixture of experts, right? And what two things are happening, right? One is there are more models out there that you can sort of learn from, even if you don't just take that model and fine tune it, even if you want to build your own model from scratch, right? Enough people have done this now, enough companies are doing it now, that it's a little more accessible what they did, and then there are reports that describe what they did and so on, right? A lot of it is still trial and error, but at least there are more people who are talking about their experience of training some of these models. The other thing, which I think is almost more important, right, that's happening, is the model sizes are becoming smaller and smaller, right? So there's a lot of work, for example, that like Mistral is doing some of this work. Microsoft here in on the west coast of the US, they've been doing a lot of work on releasing these models like Phi and so on, right? Which are like super small, like compared to the models out there, they're pretty small. They're about 2 billion, 3 billion parameters. So these are all things that you can do without too much specialized compute. Like you don't need a whole set of nodes and hundreds of GPUs and so on to do some of this stuff. And the performance of these models is also now starting to catch up and match a lot of the larger models that are out there as well. So I do think that this acceleration of, sort of efficiently using hardware, it will continue. And so it will make it easier to train some of these models. But again, a lot of it is trial and error. This is why I was telling you that, one of the big roadblocks, one of the big sort of choke points is finding engineers and finding researchers who actually can do this, right? That's a big choke point for every company right now, right? So yeah, I mean, that's really what I would say about that right now.
Anybody else? We good? Please. One more question, Karthik.
Sure. Yeah.
Hi, Karthik. So in one of the earlier slides regarding the Symbl entire architecture, there were one of the blocks was for Nebula LLM, and another block was there which was for task-specific transformers.
Mm-hmm.
So could you like explain a bit more? Where do you recommend having certain task-specific
Right.
transformers, and where do you recommend having generalized LLM models and then building on top of that?
Yeah, absolutely. I think that's a very good question, because one thing I will say is that you don't need to use LLMs for each and every task, right? So there are still some tasks, especially tasks that require, um, how do I put it? More predictable outputs. I don't like using the word deterministic, because all of these are probabilistic models at the end of the day, right? But when you require more predictable and sort of more basically outputs that you can predict a little better, then I think some of these task specific models and so on are much better, right? So I'll give you an example of a customer we had, for example, who was trying to do something like specific entity extraction specifically for like math like things, for example, right? Now, if you know exactly what it is you're trying to extract, right, you're much better off using one of these much smaller, much narrower models, because it'll give you much more deterministic behavior. Because with a LLM, the problem that I think somebody raised, like the earlier question, was that they are still black boxes at the end of the day, right? And so you really don't have too much control over the data that the LLM has been trained on. And so you really don't know if the kind of task that you're giving it is going to be an in distribution task or an out of distribution task, right? And so if you know well the contours of the problem, the task that you're trying to solve, I would say that it's much better to use like a task specific model for those kinds of things. What LLMs are great at is when there is a certain amount of ambiguity in your task, right? Or it is a very high level task that requires, combining a bunch of different things. That's what LLMs are really good at, right? They can combine a whole bunch of different capabilities in one API call, right? So for example, if I call a narrow entity detection model, it can only detect entities, right? And can only detect entities that it has been trained to see. But whereas if you're trying to do something much more complicated, where you're trying to do entity detection, but you're also trying to do sentiment analysis, and you're trying to generate some content after doing those things, then an LLM is a good use case for that, because then it's a single API call and you can craft your prompt in a way that you get the right output for it. So absolutely, I think that is a very important thing, especially on the engineering side, on the product side, right? You need to first determine whether you actually need to use an LLM, right? And sometimes the answer to that is no. You don't have to use it. Yeah. Good question.
Thank you, Karthik.
Yep.
Anybody else? Okay, I think we're good. Thank you for the excellent talk, Karthik, and again, thank you, Karthik and Symbl, for sponsoring today's event.
Yep.
Thank you. Bye,
Thanks,
Karthik.
everyone. If you have other questions, like I said, please feel free to reach